This section is a brief description of scheduling with independent tasks. What's happening here is that we don't really have any precedence relations to worry about. So this is when tasks are independent, nothing needs to be completed before another thing can be started. So there's really no efficient optimal algorithm for this, even if these tasks are independent. So here we're just going to assign the tasks to the workers whenever they become available. And without the precedence relations, the critical path time of a task is the same as its processing time. So the critical time list and the decreasing time list are going to be the exact same. So here we would just kind of resort back to the decreasing time algorithm because it's essentially the same thing in this section as the critical path algorithm. So the last thing for this chapter is relative error. And this is just to measure how close we were, how far off we were from the optimal time. So say, for example, in a project we get our finishing time is something like 25 hours, but then later we discover that the optimal time is 20 hours. Well, to find the error would just be 25 minus 20 divided by 20, the optimal time. So we just get 5 divided by 20. So it turns out we would have been 25% off from the optimal time. So that's the end of the chapter. So just go back and review some of the major concepts, some of the major vocab. Remember how important the precedence relations are in creating the project diagraph. And remember that the diagraph is really what sets the rules for making the schedule, although we use those priority list models to give us different answers and sometimes the better answer. And then lastly, we talked about independent tasks and how you can calculate relative error.